Hello, my dear friends. Welcome to Insert Electronic Channel, and today we are looking at this Windriktning designed by David Vogel, a sensor. So what is that? Apparently, this is air quality sensor from Ikea. And apparently that's actually not that super new product. It was about a release probably about a year ago, and how I missed it in IKEA I do not know. But a few days ago, just before New Year, I decided to drop by IKEA to buy some light bulbs, and I found this, and it was priced I think at $11.99. So I decided, holy smokes, I definitely gonna give it a go. And in not just give it a go, I would like to understand how this thing works. So together we're gonna embark on a journey to first understand what the heck is this, and second to understand how it works. Stay with me. What do we have here? We do have a sensor, and apparently this is what it says is include. It includes the sensor, one count, and exclude USB-C cable. I don't know why they say 1X here and 1X over here. So it's include cable and power supply. So you have to provide your own power brick and USB-C cable. Yes, this is USB-C. I saw it on the display. Not much more going on here. It doesn't even say that this is actually an air quality sensor. The reason I know it is, it was a label on the shelf saying air quality sensor. And as I understand, this is a satellite unit which designed to be working together with a not so old IKEA product. I don't remember how it's called. Okay, it's a air quality filter or air filter. It consists of like paper filter and some charcoal filter. So that thing probably supposed to work together with this thing. Why they did not include air quality sensor inside the unit itself? The reason is, so when you are filtering, it's better to keep air quality sensor further away from the filter itself. Otherwise, that's not going to be showing the actually real picture, because real picture around the filter is probably better than the real picture in the other corner of the room. That's important. All right. So let's take a look. What do we have here? It's a pretty small box, not too heavy, and let's open it. And here we are. That's the unit itself, and as I mentioned, USB-C. It's very, very simplistic. It has nothing but the grill on the back, USB-C connector, rubber feet, and this thingy, which is indicator. It doesn't have a button, on-off switch, or anything like that. That's what it is. It looks pretty sexy, actually. Here is the user manual. Why would I would like to see the user manual? Because I want to understand what kind of... Oh, here we are. So you see that they already give us idea what the sensor is supposed to measure. So when you have you burning like fried potatoes, it's gonna go up. When you have your smoke from the car getting into your window, this thing is gonna go up, which is actually useful. And there is a lot of information. And it's very, very important part of this whole thing that it measures PM 2.5 particles. So let's talk about that. So what is PM 2.5? Nomenclature: PM 2.5 defining particles which are about 2.5 micrometers in diameter. Example of such would be emission from fuel combustion, for example, motor vehicles, smelters, power plant, industrial facilities, residential fireplaces, wood stoves, agricultural or forest fires. But even simple fireplace, household fireplace, or burning oil on your frying pan is an emitter of PM 2.5 particles. Due to small size, PM 2.5 particles can travel far into lungs and cause short-term and even long-term adverse effects, especially for people with chronic heart and lung diseases. In Ontario, Canada, amount of PM25 particles monitored. Accepted level of PM25 particles in Ontario are 24-hour average 24 microgram on cubic meter and annual average 10 microgram on cubic meter. And
microgram and cubic meter is a standard measurement of amount of these particles. And of course, similar standards exist in many other countries.
So after we discussed and figure out what are the different levels of a PM 2.5 particles, now we know that are actually a pollutants, we can talk about LED indication. So we have green 0 to 35, and then amber 36 to 85, and then red 86 and higher, and pulsing is startup. So this is the different green, amber, and red, different levels. The only thing which I don't know are these percents from 0 to 100%, or these are some kind of microgram per cubic meter or some ppm, particles per millions. We don't know. For me, unfortunately, it didn't indicate here. For me, these look like they are percents, but it's weird, right? Because 100% bad can be like very high number, but we don't know. Imagine like whole room filled with this obnoxious smoke. So yeah, I don't know how to read these things. This device operates from 0 to 40 degrees Celsius. So yeah, so it doesn't operate at negative temperatures. Humidity range, okay. Unplug the product from the power source before cleaning and when it's not in use. All right, so yada yada, not much information. Then we have France and so on. So here we are. So now we know that this device measures PM 2.5 that can be, for example, produced from the smoke from your stove and stuff like that. But so I mean, there is nothing else we can do. There is nothing really, no setup. Just let's power it up and see what kind of pollution we have here in the basement. Okay, so I have prepared USB-C cable. I have prepared, and also I would like to know what current how much energy this thing consumes. That's a very important factor. I'm gonna power it up straight right away from using the TC66. All right, let's power up our USB-C power supply, and here we are. It's blinking, it's pulsing. Pulse. Oops. Cannot access those buttons. It works at 5 volt and only 60 milliamp while booting. That's not bad. Takes some time. Still booting, still pulsing, if you see this green color. Okay, it probably done booting because it's green, it glows green. Okay, as you see, so quality here in the lab, air quality in the lab is okay, and we are consuming 62. Oh, it's actually dropped. It's like 30 milliamps at the moment. Okay, so 30 milliamps, not too bad. 30, now it's 60. Okay, so it's probably just cycling within some measuring mode and then sleeping mode. Then measuring mode takes some time, and then then it's gonna go to sleeping mode. So probably measuring mode require use of this whatever sensor it is, which you're gonna take a look at, and then I think it's gonna switch. Let's see. Oh, okay, now it switched back to 30 milliamp. So that's, here we are. So 60 to 30 milliamp depending on the mode it's in. So how do we check this thing working? I honestly don't know, but I have one idea. Let me try it. Okay, so I'm not sure this is the best test case scenario, but I'm going to be using that. So we have candle, we have matches. So let's just like put it somehow right here, close to each other, and just try to do this. Let's make some smoke here and see if it's gonna change. Okay, it's still green. Okay, look at this. It's getting into yellow. Okay, it sort of works. Look at this, now it's yellow. I just tried to blow a little bit of the soot from the candle to the sensor. Okay, let's put the thing over the candle. Not over, but like above. Probably gonna take some time to kick in. I wanna just... Look at this, it's actually turned back into green. So it probably the matches was actually producing more smoke than candle itself. Interesting. Yeah, it's now green. Sorry, I'm just trying to kind of funnel the soot straight into the... No. Looks like this candle burned good, burned clean. Interesting. Anyways, so as we saw, the smoke from the match actually caused this thing to go yellow, not red or anything like that, but yellow. So, which probably a good indication. Okay, let me try something else. Oh, lots of smoke. Lots of smoke. Hope I'm not gonna kill the sensor by this smoke. Yeah, still green. Hey. Oh, look at this. I think it's turned red, by the way. It's not measuring, but I think it's turned red. Let me... Does it look red? Yes, it does look red, look. Shit, why it's so not bright? Huh, it actually indicates red, but it's barely visible. What the heck? Yeah. It is barely visible. Like, I mean, camera cannot even show it. It's weird. Anyway, so this smoke just from the candle caused this thing go red. So yeah, it was a lot of smoke particles. Let me mix it up a little bit. Did I kill it? It would be hilarious if I killed it by these particles. Okay, let me power it up and down and see what's gonna happen. It's pulsing. It's very dim, but now I understand why. Because if it's working constantly and LEDs consume a lot of current, it's not gonna be good, right? It's gonna consume a lot of energy. So it's better to have dim LEDs. Okay, now it's yellow. It's turned into yellow. So it's still detecting some particles around me here. But it's weird. It was much more brighter before. Now it's like just super dim, but it is yellow. Alrighty. So these two test devices actually showed us that this device reacts, and now we understand what particulates this thing. So smoke from the match or smoke from the candle probably soot a little bit as well, and this smoke, when I blow out the candle, it usually produces a lot of vapor of the wax. This is like soy wax, I think. So and look at this, and air quality is still kind of yellow. That's very interesting. So it takes quite a bit of time of those particles to dissipate around me. Looks even I tried to kind of use this thing like a fan to get some clean. I still feel a smell, actually, the candle smell. So that's my, yeah. All right. Okay, that's it. We know that this thing works. So let's get into more interesting thing. Let's try to disassemble this guy and see what's inside. By the way, over here, if you pay attention, it says input 5 volts, 0.1 amp. But as we saw, it actually consumes less than 1 0.1 amp. It's like 60 milliamp, not 100 milliamp. Indoor use only, obviously. It says FCC ID. Obviously, all this certified. I don't know what the heck is SE34381 Almbut. Ikea of Sweden. Very nice. Type E 2014. Air. Oh, here it says air sensor. Air sensor, not air quality sensor, it's air sensor, because it can be, detection of air present or not. It's a little bit misleading. So let's take it apart. So we have 4 screws here. I'm gonna unscrew them and then we continue. So we have our 4 M2 self-toppers out, and it's just very easy to open it up. Oh, cool. So what do we have here? So we have oh, neat. Okay, we have a sensor of a sort. We have even fan. Look at that, we have fan. I guess potentially 400 milliamp. Okay, 5 volt, 400 milliamp. Potentially this fan works. That's why it consumes a little bit more current during the actually sensing phase. What kind of sensor is this? Is it unglueable or it's all glued? Cubic, it says cubic. It's a cubic sensor of a sort. Okay, I have zoomed in a little bit and let's look into detail. So we have this sensor, it says cubic. So there is something for me to research. There is even barcode right here. Okay, so I'm gonna use this barcode in order to identify this part. We have a little fan, tiny fan, probably 30 millimeter ducted fan. Sorry, not ducted fan, the blower fan. Okay, it's in this case it sucks air through this opening and forces it through the sensor out here, I think. Yes, then we have electronic board. So one of them is controlling fan. Let me disconnect all this jazz. Is it latched? No, it's not. Okay, disconnect, fan, disconnect. Okay, we disconnected sensor board from the electronic board. Okay, we have here, what is this? We have a whole bunch of actually pinouts right here and right here. So this is something to investigate. So let's just unscrew this gentleman and see what is going on there. Okay. What is this? It's infrared. I don't know what else it can be. We have 1, 2, 3, 4, 5, 6 LEDs. And is it infrared? Looks like we have proximity sensor of a sort. Yeah, this looks like infrared LED because it's over here, a little picture. Let me take this. A little indication. It actually shows arrows pointing out. So this is LED, which is, why would you need infrared LED? But there's another fan right here, by the way, connector. Why would you need LED without photosensor? This is interesting. This is something interesting. That has to be investigated. Why does this thing here? Then we have 6 LEDs, probably different colors. Again, have to take a look at them, maybe figure out what color they are. Okay, then on this side, obviously we have some sort of microcontroller, because looks like not much else going on here. This is Q1A transistor of a sort, not sure why, probably, it's probably turned to drive the fan to turn it on and off. Yeah, pretty much it. Looks like this, there is no additional voltage converter. There is no fuse. FR, fusible resistor, is omitted here. There are 2 resistors which are just to set up the power over USB-C, which is probably could be micro USB. Doesn't really matter because there is nothing special going on here. Okay, and we have whole bunch of unpopulated pinout. So this one, there is a fan pinout. There is even pulse width modulated fan, LED green, LED green 1, LED R1. So there's even 2 LED drivers output here. And looks like those two fan thingies are wired in parallel with those two fan contacts. Maybe even wired in parallel with these two. Yeah, interesting. Then I'm gonna zoom in and take a look what the heck is this. Then we have more. We have ISPDA, SPCL, ground 5 volt, and AFST, ISPDA. What the hell, ISPDA? What is that? Interesting. Then if we go in here, we have again ISPDA, RES, is SPCLK, ISPDA. Is this SPI bus? It's not SPI typical nomenclature, and not this is not a how do you call it? I2C typical nomenclature. This is something weird. Let me research that. So I'm gonna take a photo of this board on both sides, okay, and I'm gonna post it on my website for further investigation for those people who are interested. But this looks like 5 volt logic, and version of the board is V20. And that's pretty much it. Let me take those photos, and I also do some research on this highly likely this microcontroller. Okay, good news, good news. I was able to find all details on these things. So let's start first with this little microcontroller. So our microcontroller is EastSoft. For a second, I thought this is ESP. Well, I mean, kind of ESP, right? It looks like this is EastSoft ES7P001, which is RISC 8 kilobyte flash and 1 kilobyte RAM, and I think it runs at 16 megahertz little microcontroller. I think it just communicates all this jazz and drives those LEDs. Still not sure why this is here. Okay, so this is our microcontroller, which is like some kind of company called EastSoft, and yeah, I'm not sure too much about it, so we still need to find a spec sheet on this guy to see if possible to reprogram it. Because let's talk about sensor because, and we'll figure out what I mean. So sensor is, as you see here, it says cubic, right? Turned out to be sensor is cubic PM001610006. I'm not sure if this is K or not K, but K. This is what's on their website. So which is LED infrared particle matter sensor, which can be controlled or communicate via UART or pulse width modulation, which is still figure out which are those used here. Yeah, judging by number of wires, it is UART. Because I just looked briefly in the spec sheet, which is available, and for UART you need like 4 wires, and for pulse width modulation communication you need only 3 wires, like ground, 5 volts, and the signal. All right, so this guy talks UART or PWM, and it has built-in MCU, which can measure can measure and calculate values for PM 0.1, PM 2.5, and PM 10. And this guy, which probably software in here just talks about PM 2.5. So technically, this sensor is much more capable than these controllers allow. Obviously, all datasheets provides all specs only for PM 2.5, but this PM 1.0 EPM 10 is totally available, and it outputs real-time information in micrograms per cubic meter, which is amazing as well. So you don't have to calculate anything. You essentially take the data frame, take some values. It actually says at what data frame a variable or position in data frame you take the value, and just and just output it. It's as easy as that, and it's in same time it outputs this and that, and it has also some kind of lens correction if there is some kind of dust deposit on it. So it looks like this guy is really cool. Yeah, I mean, I'm already impressed. And actually, for all this package, $11, 11.99. I mean, that's not too bad. I think this pretty much it. Not much else I can see. So now all my my fingers are already twitching. I'm already feeling like how I want to hack it to bits. So I need to think, how can I hack this thing? For example, connect it to somehow to some kind of smarter microcontroller. Completely disregard this guy. Like, forget. Like, I mean, and just connect the probably sensor straight to the some ESP32 or something, and just have real-time output of use obviously this power, real-time output of air quality in my garage, in my lab, in my bedroom at the end of story, or anywhere else. This is amazing. So I'm definitely gonna do something in this area. So try to get more information, and actually not just levels like red, green, orange. I want 24/7 monitoring of air, maybe even outdoors, maybe even just sometime we have these forest fires. Would like to know how bad is the air quality during forest fires, and things like that. So this is really interesting. I'm not sure what's the price of this sensor alone, but with this package, I think, I mean, even if it's still $11 or like $10, it's still actually pretty good thing. You can get a sensor like that, and with microcontroller and power bank and the case and then things like that. So as you see here, there's plenty of space. You can jam a lot of additional electronics right here, providing it's not gonna block the air passages and things like that. So yeah, that's a lot of space. You can put a lot of things in here. So I'm so excited to actually hack this thing to bits. Guys, please stay tuned. I'm definitely gonna be having part 2 or maybe part 3 even of hacking of this guy. I think at the moment it's gonna be it. It's obviously working. It's obviously very interesting to us, and it's obviously we're gonna have continuation of this story. So thank you for watching. See you next time. Stay safe. Ciao. And here a little bit of a bonus video. So I powered it up, and over here, as you see, the fan is actually spinning, and we are consuming 60 milliamp. Let's wait a bit and see if it's gonna drop to 30 and what's happened to the fan. Yep, here we are. Fan has stopped, and we have 30 milliamps. So that's the down cycle. It's not sensing. I'm pretty sure in this time it's sensing again. So it looks like a sense time is longer than sleep time. Yeah, there is something to measure, but here we are. We'll figure out a little bit more about this little device here. I'm still not sure what is this infrared guy over here. Still need to figure out. Unless it sends some data, like I would like to connect your infrared device and actually see what's being outputted here. It's very interesting. Or maybe oscilloscope straight to the LED to see. Maybe it outputs actually some kind of data, because there is no infrared sensor. There is no presence sensor of any kind, right? Like infrared presence sensor, that there is someone actually looking, then it's going to show the level. Otherwise, no point, right? Yeah, anyways, stay tuned.